Well, good morning, everyone. Thanks again for joining us. It is now 2021, so Happy New Year. I'm still not sure how long you're supposed to do this Happy New Year thing. I think 2 weeks in it, I think we're still okay. Obviously, you don't want to go into March on this. So today we are going on to episode number 21. Thank you, everybody that signed in early, and everybody that's still logging in. We'll give everybody a few minutes. My name is Alex Fassini. I'm the Business Development Manager and Water Treatment Specialist here at AWC Solutions. Today, we are joined by none other than Lisa Brand. She is the Chief Technology Officer at LG Sonic. Our topic today is a little different than what we normally do. We're going to be focusing a lot more on technology. Algae bloom control is not something that we typically focus on. We've taken a look at contaminants before, and we've covered cyanobacteria and cyanotoxins. Today we will be looking at algae, which is, of course, ranges a little differently, but it's still a topic that we should really be focusing on. Give me a second, we're still letting everybody in. Wow, one at a time. So I'm going to go ahead and jump on this. For those of you that don't know who we are, if this is the first time you're here, these are some of the other webinars we've done in the past from last year. As you can see, they've gone through a lot of different topics. What we focused on before, again, was a lot of it had to do with more of contaminants. Now we're going a little bit more on the technology side, as we have promised. If you'll see, if you don't have any background on AWC, if this is the first time that you're with us, AWC has been around for 40 plus years. We design and build water and wastewater treatment plants. We have close to 500, going on 600 worldwide right now. And we divide them up into different categories. So what we do is we have, you'll see that we have everything that has to do with potable water, then we go into wastewater, and of course we have skid mounted systems. So this is kind of a little bit different when we go into taking a look at algae bloom and algae control, and I'm going to leave that to you, Lisa. But this is going to go outside of what we do, but of course, any kind of polishing or anything that you're drawing off of surface water, in this case, of course, we're focusing on surface water, this is what we would focus on. So with that, I'm going to bring it over to you, Lisa, algae blooms control. So go ahead and take it away.
Super, thanks a lot. There we go. So algae blooms control. My name is Lisa Maria Brandt. Thank you all for watching today. I'm the CTO for LG Sonic, based in the Netherlands, and I'm a microbiologist myself. And when we started with finding solutions for algae, the problem itself was around 10 years ago, and it wasn't that much spoken of. Back then, algae blooms in reservoirs was still looked at something that you treat inside the treatment plant and not in the reservoir before you take it in. But by now things have changed a lot, and that's because, first of all, algae are becoming a bigger and bigger problem all over the world. But also because we are looking now differently also to water treatment and also to the effects of algae blooms and their toxins. When we look at how algae blooms should be treated, our company, we believe that.
Are you watching this? Are you watching this algae bloom thing?
We work with an ecosystem to tackle the algae instead of putting a chemical in there to actually negatively affect the algae, but also the rest of the ecosystem, making it weaker and weaker to actually deal with inflowing nutrients. And our company, we started with controlling algae 10 years ago. We are now active in 96 countries all over the world. We have over 10,000 installations, and we operate them from 4 offices worldwide. And all the technologies that we use, they are environmentally friendly and chemical free. So when you look at why an algae problem starts, first of all, when most for zooplankton. The installation over here, you can see that it's actually in a recreational area where people are also swimming, and it's completely fine. And how ultrasound works to control the algae. First of all, when you look at algae, they are able to move vertically through a water column. So they can move all the way to the water surface to take up sunlight. And then they can move also down to the bottom where most of the nutrients are. So they are capable to constantly be in the most optimal position of the water body. And that's also a reason why they can completely dominate the water body. And when you use ultrasound, the ultrasound will actually make a sound barrier on the top level of the water, preventing the algae from coming all the way to the water surface and taking up sunlight. So instead of taking the nutrients directly out of it, we take another very important factor for them away, which is sun, which they really need if they want to bloom. And when we started developing this technology, we did a lot of research. A lot of research was based here in Europe with universities. And we found out that if we want the algae to be sensitive for ultrasound and to remain sensitive for ultrasound, there are a few very important factors. And the first factor is that the treatment is frequency specific. So there are many different types of algae. And some algae are, for example, cyanobacteria. They are bacteria. Other algae are more like plant cells. And there's a lot of difference in the morphology of algae. And they all slightly respond to different frequencies. So when you start treating the algae with ultrasound, then it's also important that you treat with the right frequencies and not just all the frequencies or any frequency. And secondly, what's also important to know is that algae are among the most adapting organisms in the world, so they can adapt to almost all circumstances and become resistant to treatments as well, even chemicals. So when you're treating with ultrasound, it's also good to keep in mind that that they can also become resistant to the ultrasound. And to prevent this, it's also important that you keep changing the ultrasonic parameters that you're treating them. To do that, we developed the MPC-Buoy concept. And the MPC-Buoy concept was based on a database that we developed with universities, where we basically started testing different algae with different frequencies under different water quality circumstances to create a database to know for which algae we need to treat with which frequency. And after that, we started using that database in conjunction with the MPC-Buoy, which starts with monitoring the water quality. So each MPC-Buoy is constantly monitoring the algae type, the concentrations of the algae, the water quality information, and it sends that to an online server, where the server makes a prediction model of whether the algae are going to grow, whether they are dying, and also if we are dealing, for example, with a blue-green algae bloom, etc. And based on that, the system automatically sends out the matching ultrasonic frequencies and also makes sure that they cannot become resistant to the ultrasound. And also this information is constantly being stored in our database, also increasing the algorithms that we use, So the water quality parameters that we are monitoring is, first of all, chlorophyll A, which is a measure for basically green algae. And besides that, we also monitor phycocyanin for blue-green algae. We monitor the turbidity, pH, temperature, dissolved oxygen, and we can also add, for example, any other sensors like a nitrogen sensor, phosphorus, ammonium. They can also all be added to the platform. Along with the MPC-Buoy, there's also a database. We use this database to make sure that the ultrasonic changes are being made, but it's also if you are discharging the water or actually letting water into your reservoir, then this can all be added to the software as well. And what that will give you is that after a period of treatment, you also really know what affects your reservoir and what actions are contributing to algae growth or to a better water quality. So it really helps you to manage your reservoir better by using this platform as well. Now here's an overview of how our data is coming into the software. You see on the left-hand side, you see water quality parameters such as the dissolved oxygen and the temperature of the water, the pH, and the redox. And on the right, you see the chlorophyll in the green line, the blue-green algae or the phycocyanin in the blue line, and the turbidity below that. And where you see the little M's in the graphics, this is where ultrasonic programs were being changed. So you really see that once the ultrasonic program is being changed, then also you see a response in the algae by decreasing. And this was an installation done in 2014. And you see actually, if you look in the temperature on the bottom left, you see that the temperature is constantly increasing. This was an early season installation, where the first M, this was when we were dealing with a diatom bloom, and the second program change, we were dealing with a blue-green algae bloom. Then finally, just to share with you also a case study. This was actually a project of ours in the Dominican Republic, and this is Valdesia Dam. It's a 7 square kilometer dam, so these are relatively large reservoirs. And this was actually the water source, the primary water source, the only water source for an entire city. And due to algae blooms, they were actually not able to drink the water anymore. You can see on the pictures over here some more pictures of the blue-green algae in the reservoir, and here as well. So their problems were pretty severe, and they weren't able to treat it anymore. We installed 50 of our MPC-Buoy systems over there to cover the entire reservoir, so to prevent algae really in the entire reservoir. And after the treatment, we could see actually a reduction of 70% of the algae in that reservoir. You can see just a sample of the water over here. And over here, you can see the installation of the different buoys in the reservoir. So a lot of people, when they hear, okay, 50 buoys in a reservoir, that's going to cover my entire reservoir. But the units are actually relatively small, and they're spaced out around every 1,600 feet. So once you actually have them in your reservoir, they don't take up a lot of space, and recreation, for example, is also still possible when the buoys are installed there. And we reduced the algae count with 70%. And since the systems have been installed, which is for 1 year now, the city has been able to continue to use their water. Here is also an image, a remote sensing image, which is something that our company can also do to support the data coming from our buoys. We use a satellite for this. So satellite images we use to calculate the levels of algae, in this case chlorophyll, over the entire surface of the reservoir. And what you see over here is on the top an image of the reservoir before we started treatment. And you can see how the algae are spread through the reservoir. And this also helps us really give an idea of how the algae spread from point to point and how our measurements translate to the entire reservoir. But in this case, it also gives a very good overview of how the reservoir looks before and after treatment, because you can really see where on the bottom picture where our buoys are installed, that the reservoir, the water was clear. There was much less algae, and the yellow area that you see on the top of the reservoir, this was at that point actually dry. There was no water in there, so that's the reason why it was yellow. The results were very good, and it also was for us a reason to go into more projects in the Dominican Republic as well, and look into expanding our technology further there as well. That was the end of my presentation. Let me see.
Excellent. So now we can thank you for that, Lisa. That was actually perfect timing. We did want to open it up for some questions, simply because I know that when this was originally sent out, we actually had a bunch of emails that came in asking us for, well, how are we doing with seawater? Does this operate on wastewater? How do temperature variants change the performance on this. So we wanted to make sure we left enough time where we can pack everything in 20 minutes. Oh, look at that. So I have a list of questions, but I've got Tom here that's raising his hand on a question. So go ahead, Tom. If you want to turn your mic on or turn your camera on, go ahead.
Thanks, Alex. Lisa, I was just wondering how much effort is involved in maintaining the instrumentation on the buoys. I know turbidity can be pretty finicky, and maybe DO, and maybe you need to clean the sensors periodically. How much effort is involved in that?
So the sensors are all self-cleaning. So we have wipers on the sensors that do the cleaning on the sensors. So what we recommend is to, well, depending a little bit on the water quality and the turbidity of the water, to go out there every month or every other month just to do a general checkup of the sensors and also of the solar panels. And we recommend to calibrate the sensors every year. And yeah, that's basically it with the maintenance.
Okay, so I have another question here on some of the images you showed were the difference between a blue and red algae. I guess the short version of it, what would be the main difference between the two?
So you mean on the images that in general, a red algae is a red algae bloom. Over here, this was not like a red tide. This was an algae blooming in the reservoir. I think in this case, the algae were decomposing in the reservoir and were therefore giving those brown layers.
So it would have been something like older blooms that weren't being affected anymore. Okay, so I guess going back to the
we use our technology. We've tested our technology for fish and zooplankton and also for aquatic plants to make sure that there's no effect, and we actually only see a positive effect on them not because they like the ultrasound so much, but because we make the water quality better, which is also good for them. For a fish, it's also not very nice to swim in a toxic algae bloom, to say the least. And when it comes to animals outside the water, the ultrasound itself, it generally is reflected by the water surface back into the water column. So when we make our measurements outside the water, we see that the ultrasound we can't measure it after about a feet above the water surface. So we don't see that there can be an effect, for example, on bats or anything living around the lake. They won't be able to hear it.
Okay, and then I guess outside of wildlife, we're comparing freshwater versus seawater and wastewater. So I guess the question was, could you use something like this for all three?
Yes, definitely. So we have applications in both fresh and seawater. We also have a special systems that are installed in seawater that are more resistant to corrosion. When you would install in open sea, there are of course some mammals that may hear the ultrasound that would be a harassment for them. And for this, there is a list of circumstances that are set that an ultrasonic machine should comply to, like the amount of ultrasound that it sends out and the timing. So we make sure that our programs fit to that, so that they are not an harassment for example, for marine life.
Okay, and then a follow-up to that, because we're comparing freshwater to seawater, would you have a different frequency? Like I know that you mentioned, changing frequencies around. Would you have a different frequency if you were going from, say, seawater to freshwater?
Yes, usually we do. Also because we are usually dealing with different algae types when we are treating seawater.
Okay, right. So the algae type would be the reason why you would be changing the frequency, not necessarily the water composition itself.
Well, the water composition itself also takes part in how the ultrasound how the ultrasound is transmitted to the water and how efficient that is. But it's also a little bit depending on the case that we are actually treating and why we are installing the systems at that time. So if we are treating a system where there is more
another one for you. So does the unit continue to operate during winter months? So, there's no algae, colder climate.
Usually, well, in some applications they do, but usually we recommend to remove or at least turn off the unit when the temperature reaches 0 degrees Celsius. So when the water reaches freezing conditions. Also because the unit, it has lithium batteries, so it will be better for the batteries, and there's usually no algae then anyway, so it's also a good time to calibrate your water quality sensors.
Okay, well that kind of answers that last question here. The question had been for water sources that freeze, mind you, we're in Canada, so for water sources that freeze during the winter, how difficult is it to remove and reinstall over the winter months? So I guess that kind of answers the question. Ideally, you want to make sure that we remove them, so you're not just letting them sit out there in cold temperatures.
You can leave the buoy itself in there, but we recommend to take just the transmitters, the ultrasonic transmitters, the water quality sensors, and the batteries out. But of course, it also depends if a lake freezes over solid a couple of meters is different than when you get a little bit of ice. So that's of course also depends on the circumstance.
Okay, perfect. And I have one last question here from Mark that says, to my understanding, the algae die-off will result in elevated toxin concentrations in the water due to algae cell breakage. How will that affect the overall efficiency of the water treatment?
So where our system is really different from, for example, a chemical treatment, is that when you would treat with chemicals, you let the algae basically grow to a certain concentration where it becomes a nuisance. Then you dose the chemical, and then those cells start to die, usually overnight, and decompose, and you get a peak in toxins. But when you're treating with ultrasound, you start preferably at the beginning of the season, not necessarily, but you start with your treatment, and the unit, it starts suppressing the growth of the algae. So of course, your initial algae, the initial algae that are in there when you start the treatment, they will die at some point. But they will die anyway at some point, whether you do provide a treatment or not. Those cells have got to die, and they are going to release those toxins. But the difference is that the ultrasound is going to prevent the growth of new cells. So what we see when we place our treatment is that you see a toxin concentration, if present at the start, just basically starts slowly reducing when our system is introduced.
Excellent. So we have more questions coming in, but we are going to wrap up. If anybody wants to stick around, I call it the after party. If anybody wants to stick around, we can continue having a little one-to-one here with Lisa. Please do. We're going to go ahead and cut it off. Before I do that, however, I do have to do one shameful plug. All of this is being recorded and it's being published on our somewhat new YouTube channel. If you want to go back and review this, or if you want to share it, please make sure that you can tune in there. Tomorrow morning, we're going to be sending out a link to everybody so you can have access to the videos. With that, Lisa, thanks again for everything. I am going to include your contact information in there, so if anybody has any questions. So thanks again. Last quick reminder before I forget, we are changing this now to a 2-week format. So rather than doing this every week for a lack of time and making sure we have enough time to schedule everything, we're going to be doing it every 2 weeks. Thanks again for everybody for joining. Again, if you want to stick around and do some more questions, please do. So thank you, Lisa, and bye-bye, everyone.
Thank you, Alex.